Hi guys, it's been a while, but I am back to making videos. So, today we'll talk about collecting metrics and logs from Docker containers. So let's start. So, what's the context? Some context. The context is that we have a system that can be deployed on one or a few machines. We don't want to bother with Kubernetes complexity. So we can just use Docker, but we still need to have a few tools, scripts that will simplify our life and operations in general. And this is one of these tools. This is basically a tool, an app that will, in an infinite loop, collect metrics and logs from all running on a given machine containers. Metrics will be exposed to Prometheus and the logs will be saved in the local file system, but you can also save them in some database, send them to Elastic or whatever. For the sake of simplicity, in this example, we save them to the local file system. So let's get to it, guys. First, we'll go over how this script works on a more or less high level, and then we run a few containers to see what we can do with it. So first, I will be using this README that I've prepared to go through example. And so before running the metrics and logs collector, let's see more or less its code structure. So everything is in the, I will link the repository in the description as always, but we have a few files basically. Collector, containers, logs exporter, metrics exporter, and some utils. And in general, it is the whole tool. It has a few hundred lines of code. It's not that long. Collector is an entry point, and at the start we have some environment variables to configure a few things. So we can change metrics collection interval. So how often we collect the metrics, how often we collect the logs. We have also assumption that logs are always collected not at least as frequently as metrics. So metrics they can never be collected more frequently than logs. We have path to files that basically we save timestamp of when we have last collected metrics, we have last collected logs. It can be used for external tools to synchronize state with us. So for example, waiting for our script to finish before killing the containers. We can specify how many collector threads we want, because collecting metrics, it can take some time. And we have exporter port, which is a port of Prometheus exporter, because as you should know, the Prometheus, to expose metrics to Prometheus, it just means that we have one HTTP endpoint where we have all metrics that Prometheus can scrape for us. So then we have graceful shutdown. It's just a class that allows us to stop our program in a graceful manner. Then we, as I said, we print some config that we have set up for our tool. Here we have the assumption of logs collection interval being always higher than metrics collection. Lower. If it's higher, we throw an exception. And here's the function that we use here in the containers. Containers is a class that serves us as an API to fetch currently running containers, getting logs and metrics from them. So to use it, we need to have a connection to a Docker client. And I think I didn't say that, but to interact with Docker and the requirements, we have dependency on Docker client and Prometheus client. And we just have our wrapper over those libraries that allows us to give us better API for our needs. So here we connect with containers, and then these two functions. Before going to them, let's go to the actually an entry point, which are where we invoke a few functions to start our program. So first we export metrics to Prometheus, and then we just print where they are exported on which port, and then we keep collecting and exporting them. And here is the infinite loop that I was talking about, where in infinite while we have a thread pull executor to collect metrics on a few threads to make it faster, but in a nutshell, in an infinite loop, we collect metrics. We're not going into details right now, but in general, we always collect logs, and when we need to collect metrics, we also collect metrics from all running containers. Then we sleep, and while is infinite. Or we can also shut down our whole app, and then it stops. And what else? Here we fetch the containers, we print a few of them, we collect and export metrics. So maybe let's go here. So we have containers, we collect them on executor, and then using metrics exporter, here we have a few metrics defined in the Prometheus. We go there and see them in a while. Right now I thought that it would be pretty useful to go through the code. And in the logs exporter, it's used in a similar manner, but it logs to a file, and here we are just using the rotating file handler that allows us to log directly to files, and it rotates files for us. So we create a logger for each container, basically. We will also see this in action in a moment, but what I wanted to show is that we also have metrics for logs. So here we have a simple metrics per container logs total, and we have a level here. So we classify logs according to their level, which for us is warning, error warning, and info. And we also, thanks to that, we can also have alerts. Right, so I think it was too much details actually. So let's start the collector. It is Dockerized, and you can also run it without Docker. You just need to have Python and those requirements that I described, but basically in a you can see how it is defined in a Docker file. So we have Python requirements, we install them and run the collector. So let's do that. So I should be in the correct directory. Let's run. It can take a while on your machine because you may not have this base image, so Docker then needs to collect it, download it from the net. But from me it should be pretty simple, pretty fast. Right, so I started because I used this script. So as you can see, it runs in the detached mode. So if we go to the terminal, we should see this. Let's see logs. Logs are similar as in the README that we were going through. So we print some config, then client Docker version and some details about the client, and then we are checking one container. And actually we have one running container because also the tool itself, metrics and logs collector, it runs in Docker. So that's why we are showing those things. So actually, because as you may remember, and we can also see from the maybe from, not from this, but from the config here, we have a volume here, and the logs, they will be available under this directory. So let's go there actually to temp directory. And we have some, we have last logs collected at. These are the files that I was talking about. We insert here the timestamp after every collection. It can be used by external tools to synchronize killing of Docker containers, stopping them, and so forth. But let's not bother with it right now. If we go to logs, we will have a directory for every container. Right now we have one. If we go here, we have our logs, guys. So we can see that they are sent. As they are collected, you can see that if you wait for a while, this is the last log. And right now it is something different. Okay guys, but the collector, it doesn't give us anything by its own. We need to have some containers. So for now, let's stop it. And let's run a few containers that I have prepared for examples. So if we go to containers directory, let's maybe show them. We have logs browser, PostgreSDB, Prometheus, some custom app, and we have script to start them all. So let's start them and see what we can do with them basically. And on your machine it can also take a while, because in every folder you have a Docker file that has some base image, and it may take a while to download all of them from the network. So take that into account, but let's run this. Okay, our container should be running. So let's see. Yeah, we have a few containers. I stopped the logs, metrics and our metrics and logs collector on purpose, and to show what kind of tools we have before diving into its features. So let's go to, it is also all described in the README if you want. So we have Prometheus, and as I believe said, here we will have all container related metrics. So we can do something like that, and we shouldn't have anything. Yeah, we don't, because the metrics and logs collector is stopped right now. We also have logs browser, which basically give us ability to see logs through browser. It is just nginx that points to this this directory with logs that we this one, but this one, sorry, not that. Metrics and logs collector, logs. Yeah, so this one, we have one directory and one log, and it's quite nice because we can see all logs here, and in many cases it is all we need to search through logs. Alright, so let's get back to our containers. So we have a few containers, and one more thing is, let's see their stats. And on purpose, I have created some custom app. It's a Python app that makes given amount of cores busy. So as you can see, it takes 300% of my CPUs because it runs on 3 cores. I have 12, if I'm not mistaken. So it would be able to take over 1000% if we allow it to, and we'll use it to see how it compares to metrics collected by our tool. So right now I think we can start the metrics and logs collector again. So it should be ready. this. Also, as you can see, its CPU usage is also pretty low. Most of the time it doesn't take anything. When it wakes up, it collects things, metrics and logs, so it takes them a little more, but it's still low. Okay, so let's see the logs actually of metrics and the logs collector right now. Yeah, as you can see, it is collecting. We have to check containers, and we have a few containers, which are all containers that we are interested in. 5 running containers, I believe. Let's see what it should be. Yeah, we have 5 containers, and in the infinite loop, we always, as we can see, we always collect logs, checking the logs, and sometimes also metrics / stats. Okay, so also my fan is getting quite noisy. I don't know if you can hear it, but because some custom app, it takes 3 CPUs. Let's actually change it, guys, because we can. So let's stop, go to containers, and let's stop all containers, because we also have a script to do this. We have only metrics and logs collector, and for some custom app, let's change it. So because we have an environment variable, let's just make 1 CPU busy, and let's start them again. Let's see. Yeah, so it's better, and we should have multiple logs right now, guys. So let's see. Not this one, but let's go to the root. So we have, let's go to the logs browser. We have some logs, and for some custom app, we should have, yeah, because it computes something also in an infinite loop, and also sometimes on purpose I log things on error. It's also easy to search errors in this browser. Yeah. So we have logs, as you can see. You can also see that they are collected as they are logged in the real time, because you can see the date, and we have something different as I am refreshing the page. Okay, so that's quite nice, and let's see what kind of metrics we collected. Okay, we have multiple metrics. For example, let's go with this guy, which is CPU usage, and we have 5 containers. As you can see, we also have instance, job, and machine labels, and most containers, as also according to Docker stats, they almost don't use CPU at all. Only 100%, more or less, which is 1, because here we have 0 to 1 percentage. You need to multiply it by 100 to have something similar to that. It is more or less the same. We can also, I don't know, let's change it to 2 CPUs, for example. Let's stop containers. Start them again. Okay, and let's wait more or less 20 seconds and see what we'll have here. Here we have 200%, and here we still have old value, yes, and right now we have also 2. All right, we also have alerts that I didn't mention. These are standard Prometheus alerts based on the metrics that we have. So one more interesting, and will be about log errors. We will, because we can configure it in an interesting way. We'll go here in a while, but let's maybe show how this guy works. Basically, we have container uptime sub-seconds gauge that it is updated after every logs and container logs and metrics collection. And as you can see, if we subtract it from current time, it should never go past like 40 because we collect it, and we have alert if it goes past 60 for any container. So let's actually stop the, I don't know, some custom app, for example, and let's wait for a while to make it active, because right now there should be a difference. It is, as you can see, 7 seconds, and here it is rising for some custom app. And 20 seconds from now, the alert should be fired. And if we go with that Prometheus metric, you can also create dashboards in a Grafana for it, by the way. I probably will create another video about that. But if you do this, we only have container logs errors, because some custom app it was reporting them. But yes, let's wait for this guy to be active, and as you can see, it is. So I guess we should have an alert. Yeah, we have. So we have that container is down. We can also show it on graph. So here the container is down, and let's start the custom app, and let's go again, and after, I don't know, sometime 23 seconds, it should go away, the alert. Let's see, still up, right? Here I guess it will be for some time, but for our purposes it went away. Okay guys, so what else we can do? As you can see, you can do a lot, because we have many metrics about containers. We also have memory usage. So for example, we have alert for memory usage %. So you can take container used memory bytes and divide it by the limit that container has. Yeah, as you can see, it's quite low, similar to that actually. And for the CPU usage, actually, to make some kind of alert based on that, we need to also take into account how many CPUs are available for the container. So for that we have CPUs available metric, because for example, it may seem like a lot, this 200% for some custom app, but it has 12 CPUs available, so it still has a lot of resources in the tank. So if we would do this CPU usage %, we should divide it by CPUs available, and here we have real usage. So it's only 16% leave for some custom app. And to make this point clearer, actually, let's add let's add a limit. So I think it was CPUs, and let's give it 3 CPUs. Stop our containers. Let's start them. Yeah, and let's wait. Here we'll have the same, but we should see change metric. Yes, we have 3, as you can see, and here it is 66% because we take 200% from 300 available. So keep that in mind, guys. And one last thing that I wanted to show is container logs total metric. Here we have logs with their logs, the number of logs event with their associated level. And what's important is that I allow to customize classification of logs. So what does it mean, guys? We have log levels mapping JSON, and here we have configurable rules of how we classify logs. So if we have default mapping that it is applied to all containers instead of ones that are matched here. We go here in a while, but default mapping is, as you can see, that if in logs message we see warn or warning, we classify it as warning. If error, we classify it as an error. But we can also have a custom mapping, and I have defined the custom mapping for our some custom app. It is always almost the same, but we can also specify messages to ignore errors. And if we specify if something in a log contains words that we specify here, it will not be an error, it will be an info message. So to illustrate that, we can go to see what or we can use the logs browser. We can see what some custom app is logging, and with error it is saying random error. Okay, so if we create a plot of logs, actually let's do that. Let's have a graph of 1 hour. As you can see, it only increases as some custom app is logging errors all the time. So let's change the rules. So let's add in messages to ignore errors. Let's add this message, because on error we only log with error we only log random error and some value, but value doesn't matter because we just do contain checks here. So if in a message we have this, we'll ignore it. So let's actually stop our containers. Okay. Yeah. So we don't need to stop and start containers. I should just restart the metrics and logs collector. So let's do that because it's defined there. Okay. So let's go to it is still rising, but if we take it's 15 minutes, it actually should stop. If I did everything right, we can actually also recheck something, docker ps, and let's go to metrics and logs collector and that interactive mode, and here we have config directory, and let's see whether yes, we have random error. Yes, and as you can see, we don't have errors. And let's see the 5 minutes. It is still up because it takes into account the last 5 minutes. But if we do 1 minute, I think, yeah, 2, still okay. So I don't want to wait, guys, but after 5 minutes we wouldn't have this error. If we actually do what we had previously, we don't have errors, as you can see. Yeah, we have, because it is an increase, but if we do not increase but just the counter, we just don't have value. And if I were to restart the collector and we wait about 20 seconds, you will see that we will have errors here again. So let's wait and see actually. Okay, let's maybe follow the logs we should be collecting. Okay, we are collecting. So the browser, yes, we have errors. So maybe let's decrease the scale. As you can see, 2 errors. We should have more after a while. We also don't log them that often, if I remember correctly. But yes, they go. Okay, guys, I think that's it after my break off from making videos. Like the video, subscribe to the channel, and I see you next time. See ya!